Okay. Um,
Last time we write methods and functions. Can you remember
yeah,
that in Java?
yeah.
But why
I
we
mean,
do that?
because if you don't write methods, then you'll have to repeat the same codes over and over again.
This is from the perspective that you have seen. Yes, it's true. But
Yeah.
in reality, also in real life, um, I mean, it's easy to scale a big program if you are dividing your code into functions,
Yeah.
and it will be messy to write very large code if you don't
Yeah.
divide them into also functions. Okay.
Yeah.
Um, mm, mm.
Yeah.
okay. Let me then. Um, Also, it is not considered. So it's not considered a good programming practice when you have more code. Actually, the measure of a good programmer is about the functionality, not the amount of code that you write. So we want to introduce you to something called decomposition and abstraction. So decomposition means that if we have a big problem, how we divide it into smaller problems that we are able to tackle. So we don't handle the big problem one shot. Let us try to see this. So a projector is a black box. Do you know how the projector works?
Yeah.
You know
It
how it
like,
works. Okay. But we do, I
yeah.
mean, we don't know inside how it works.
Yeah. Yeah.
We know how to handle and use it. We know how to we know the interface of it. We know how to pass it an input and get an output of it. What is the input of a projector? What is the output?
Uh,
Did you handle
I
any
mean,
projector in the school before?
yeah. Yeah.
So what do you use it for?
It's like you use it to display. It's like a screen basically, so it like displays an image on a wall or whatever.
Yes,
And then
okay.
yeah,
So
so
you connect it to any electronic device like a computer or
yeah,
something that communicate
yeah,
with the input of the projector, right?
yeah, yeah,
So inside the black box, they convert the image from the input source to the wall and magnify it.
yeah.
Okay. So the abstraction here that we're talking about is that we don't really need to know how the projector works. So
Mm.
we talk that this is similar to how functions work. So projecting a large image. Okay, let me see. So not every function that we're going to use, we know how it works. So we can use function by passing it input and getting an output from it without really knowing what the function do. So like, for example, if you remember this mass dot power, can you still remember that? That takes 2 and 3, and this it raised 2 to the power of 3. Can you remember that method before?
Yeah,
You can still remember it? Really?
yeah, yeah. The Java method
Okay.
for
So yeah. So what I want to
yeah,
say that this is a method you don't know how it is, how inside it works, how it do the job for you. You just pass it an input and you expect an output which is 8. Am I right?
right.
So this is what we call abstraction. So we don't care about what is done inside the function. Now, if we're talking about a projector in a different way, projecting large images for Olympics is decomposed into separate tasks. The separate task is that they create separate uh, small projectors. Each projector takes an input and produce a separate output. All projectors work together to produce a larger image. So it means that the large image in the Olympics, actually, if you look at it, you will find it composed of small projectors. Each projector is responsible for producing part of the image.
Right.
Okay. By grouping this small projector together, they make a very big screen that is used to display the large image in the Olympics. what I want to say is that we decompose. The decomposition idea is that we cut the big task into smaller tasks, and then we handle them to achieve the same goal. So to be able to solve a big problem in your code, so we create small functions, not necessarily small, but we handle that by creating different functions. When these different functions are employed in your code, then you are able to solve your problem. Okay, so we will see that how it will actually work. So, okay, let me see here. Okay, we would like to talk also about modules, because there is something called modules in Python or in programming. These modules is that you group some amount of code that do a specific purpose or solve or have a list of functions. For example, the math is actually a library. The math that we use it, .power and .sqrt, it's actually a module that have a list of functions inside, and it's self-contained.
Yeah.
We are able to reuse it. So it's reusable, it is organized, and it keep our code clean because we only call it when we need it. We only call it when we want to use the .power or the sqrt or square root, but it doesn't make our code messy. Why? Because we only need to call it this way. Okay, how is it implemented? It's not our business. It is already stored in the module. Okay. Okay, and so we consider the module or the math library here is a black box. Okay, so let us talk more about functions. I know that we supposed to know how function is actually used. We need a name for a function. We need a parameter. It can be 0 or more. We need something called docstring. Docstring, a string, actually we didn't see it before in Java. And we need a body, and that's normal. And we need a return statement most of the time. So have a look at this. Can you understand what is this?
Okay. Okay.
It seems that it's tough, is it? Is
It's
it
a bit
confusing to you?
confusing.
Okay, why? Why is it confusing? Okay, now let us. So before we use different keywords to define functions in Java, right? We use public. Sometimes we use static, and sometimes we use void. Am I right?
Yeah.
So we use all this just before we define a function, and then we provide a function name. But here we don't need to do that. So this is all keywords in Java. But here you only use define, and then you use the function name. So the function name that we used here in Java, it can be also it's called is even also, no problem. And then we have this parameter list. Okay, but here it's slightly different. we use here colon. Okay.
Yeah.
We don't use square curly braces like Java. Here, def replace all this. We don't have a return type here. We don't write a return type. Python does not need this from you. You return or not return, you don't need to care about putting anything before your function. Okay, so it's just simple. Define function name, list of parameters, and then you start writing the function itself. Okay, so where is the start and the end of the function is defined by the indentation. So once you start writing from here, so this is the end of the function. Okay, clear? And now we have something called docstring. Docstring is actually a piece of amount of lines that we write text inside it. So what is the marking of that? We use 3 double quotations like that as to mark the start, and this is to mark the end. So by using 3 double quotations like that, we write, this is optional, first of all, but it is a recommended practice. It could be, you could lose marks in your exam, and some of the companies are strict. They kick out people who doesn't follow the procedure that or the guidelines that they put for their workers or programmers. So this is, I would say, highly recommended optional thing, which is you write what is the input of your function and what it does and what is the return. So here you say I take I, and it's a positive int, and it returns true if it is even or otherwise false. So you are describing what your function is doing. So this is a doc string. So are we able to use hash? Yes, we are able to use hash. But the doc string is actually marking, how to say, sometimes we put it up, but I think one of the recommended places is to put it inside like that. The point here that the people who use this function, once they see that, they are able to know what is it for. Okay, did I make myself clear? So did you understand now this? I think this is easy. This is the body of the function.
Yeah, okay.
Is it clear?
Yeah.
Okay, so is it clear how we call the function like that?
Yeah, it's
okay.
like the same as the normal method.
Okay, can we write this function, please?
Okay. Is this written like on Python? We don't really have to worry about brackets.
Yes.
Yeah.
So the indentation is actually the one that replace
Yeah.
curly braces, yes, and brackets.
But does the like this the second box, right? Which has the input I and all that. Like that doesn't really have any code, right? So what's the point of writing that?
Okay. So you can understand this, how to say, this is a comment. Okay, this is
Yeah.
a section that you write a comment. This is necessary I mean, it's a good practice that you do it as a programmer, because you are not
Yeah.
going to work only alone on a project, but you're actually going to have people with you. And not only this, and when you write a code after 6 months, sometimes you will never remember why you created that method or function. So it is for you and for other people to read that fast, to know why you created that method and what it can be used for. Okay, so if you don't, then people have to go through the code to understand what you are doing. So, but this is not a recommended practice, and not a fast or efficient way to use the programmer time. So that's why, yes, it is not going to be executed. It will be marked, and the compiler or the interpreter of Python will actually skip it. Okay, but it is needed as a part of your functions that you build. And if you say that, oh, I will understand, yes, I understand. Most junior programmers does not understand why this is needed, and does not really follow it until they are punished. I'm sorry to say this, but at the end, once you stay in the job for more than 6 months, and then you start to see other juniors who don't write that, and then you start to find it messy. So 1 year, you find a junior left the work, go to another company to get a much higher salary, and then you find yourself responsible for his code. And then you see the spaghetti, and then you start suffering. Then you start to become senior by seeing spaghetti code from juniors and fixing their spaghetti code and writing documentation for other people code. You will suffer. So you will understand. You will start to understand why people need to do that. Or only then you will start to appreciate that seniors always use this kind of doc string. But so if I don't teach you, then you will never know it.
Okay.
Did you manage to finish?
Yeah, I wrote it.
Okay. Did you run it?
Yeah, 1 second. Yeah, inside is even, it says.
Okay. May I know, did you print out something?
Yeah.
It's
Only
just inside
is
is even. Okay.
Yeah.
So may I know, do you understand what he's doing here?
Yeah, that is checking whether it is even or odd.
And it will
So
return
if
what?
the remainder is
What kind of return, or what we're going to get out from this statement? Are we going to get an integer? String? An integer, sure.
Integer, yeah.
You sure? You sure?
Yeah.
You sure? You sure?
Oh, no, you get the double, right?
Okay. Okay.
Correct?
No, you are still wrong. But let me see here. What is the next slide?
Is it not?
No, we don't see that. Okay. So I would say put this in a print statement. I think it's easy. It's not like Java, right? So just put this in a print statement.
Yeah, okay. Oh no, this will give you true or false, right?
Yes. So
It gives
this.
you a
So
Boolean.
when you yes, good. So when you do this printing for what this function returns, it will actually give you what this is returned to you. So this expression evaluate to true or false. So this is equality check. So we're checking this portion is equal to this portion or not. Okay, so we will get true or false. Previously, we use it in an if statement. Okay, but again, we want to write efficient and less amount of code. So we are supposed to write, previously, we wrote this code in an if statement. So we should say return true, else return false. But we replaced these 3 lines or 4 lines with this only. So if I would say that you need to write that, so there is many options. And also there is another way that you can say result equal so this will store Boolean inside the result, and then you say return result. So here you took another step that you evaluate this, you store it in a variable in the memory, and then you ask him, so you allocate a variable in the memory here. This is a step that is needed by the processor to do. Oh, and then you return that result variable. Okay, but here we didn't do this. We didn't do that. Previously, we always do this. So did you understand me here, or is it still not so clear?
Yeah, I understand.
Okay, did we do that in Java before?
Yeah, we did.
I mean,
similar to this.
Similar to this, using if statement or using just one line like that?
I think we did both.
Okay, that's good.
I think so. Yeah.
Okay, now may I understand from you what this guy is? No, this is, I mean, okay, do you understand first? No, I mean, wait. I want to let you know here, this and this is keywords that belong to Python. You should never use them in any variable names or any function names. So this is keywords. Return and def is belong to Python. You should never use them. Same goes to Java. Yeah. The keywords that belong to Java, we should never use it in something else. Other than that, I would say I would move here. So we talk about here about variable scope. Please read the code provided to you here and tell me what do you understand.
Okay. Yeah, okay.
What
So
do you
this
understand?
is just like a method for an equation where you're just adding one.
Okay. But I want you to actually look more deeper, because the scope is a dangerous topic, especially here in Python, because everything is open. Do you see we are passing x here? We are changing the value of x, and then we are returning x. So
yeah,
what is the difference between this x and this x?
Yeah. This x is a
1
is like
and 2. So tell me which x you're talking about, number 1 or number 2?
So number 1 is like, how do I explain? Let me see. Number 1 is like, how do I say? It's like, I don't know how to explain it. It's like number 1 is the is like the input.
Okay.
for the
Okay.
method.
Fine. Okay, I accept that. Yeah, that's good. Okay,
But
so this x will end up being what? So from what you see here, what is the value of x that we're going to return?
wait, value of x. Oh, value of x that we return will be, oh, here will be, is it 4?
Yeah, why you're not confident? Yes, it's 4. Okay.
Yeah.
So when we return 4, we going to store. Sorry, we need to close.
Oh, okay.